I'm still. Hey everyone, hopefully you can hear me now. We're gonna get started shortly. So we're just gonna wait for people to join. We're using a new broadcasting software, so if we have done, if we do some silly things in terms of which screens are shared or whatever for a moment or two, it's just us getting used to this new software. So while we wait the last few minutes, so that we start right at on time for anyone that's joining. We're going to be using the webinars channel for the chat on Discord. Oh, sorry, on the Try Hack Me link, guys, the Try Hack Me apparently is having some issues with the direct linking. You have to go click on My Rooms and then use the last part of the URL where it says DLL Hijacking to enter the room. I'll show you here. I'll pull up my screen real quick to show you guys. So if you click on rooms, there's this enter room thing down at the bottom down here where you enter the DLL hijacking, the last part of the URL after the room, and click enter room, and then you'll be able to enter it. Okay, and it is noon, so or noon my time, 10 a.m. Pacific. So we're gonna go ahead and get started. So we're gonna be going over DLL hijacking and then walk through Invoke PrintDemon. Oh, I have a typo on my slide. Invoke PrintDemon to as a case study on how DLL hijacking can be leveraged and combined with other CVEs to get persistence and privilege escalation. So I'm Hubble, Jake Krasnov. I'm the CEO for BC Security. I got back. I started off in astronautical engineering, and then I was a red team lead in the Air Force for about a year. And now I've gotten since left the Air Force, and now focus on embedded systems security. And then Coin can introduce himself.
Yep. So I'm Coin, or Anthony. My background's electrical engineering. I've done a lot of work on embedded systems, a lot of IoT devices as well. I did some work on Bluetooth locks a couple years back, hacking those, and did a couple presentations on that. Now I'm mostly focused on enterprise systems, working on the enterprise project as well as Starkiller.
Cool. So we like to, when we teach this kind of stuff, we like to tie it all back to what our 8 stages of like a red team engagement that we've broken out. And DLL hijacking can be both a persistence method as well as a privilege escalation method, depending on how it's employed and what application you're abusing for the DLL hijack. And that's just, this is just one technique in each of those stages. Like we have a course upcoming where we walk through all of these stages and a whole bunch of different techniques. That's going to be out in June. It's our advanced threat emulation course. If you guys find this enjoyable and want to learn more about this kind of stuff. So first, let's just real quick go over what is a DLL. So Wikipedia gives a useful definition of it is Microsoft's implementation of the shared library concept in the Microsoft Windows and OS/2 operating systems. Which, what does a shared library really mean? It's what it sounds like. It's a file that contains precompiled code or data that can be shared between multiple executables. So this allows for executables to be smaller because you don't have to include every piece of code required in your executable. You can load a DLL that's common across multiple applications and reduce the footprint of software in general. It allows you to only utilize resources as needed because sometimes DLLs don't have to be loaded at runtime. They can be loaded, at startup, they can be loaded when they're needed at runtime. And then it just makes reuse of code easier. Like if there's a driver you need access to for doing something like with a webcam or whatever, like you just have to write the code once, then you can just use that DLL across multiple applications. So DLL hijacking, as I said, can be kind of a blend of privilege escalation and persistence. PrivEsc typically requires access to a restricted file location. As you can see in the image here, this is the one that we're going to be abusing for Invoke PrintDemon. You have to have access to System32, which a normal user can't access. That typically requires admin privileges. Part of what we're going to be going over with Invoke PrintDemon is a CVE that allows you to access to that folder and why it works. But DLL hijacking in general takes advantage of search patterns for DLL loading because DLLs are not always located in the same spot. And sometimes programs need different versions of the same DLL, so they will put them in one location so that they can override it and still not have any issues or incompatibilities. So there's a couple of different search orders that are utilized for DLL hijacking. For Windows Store applications, it first checks if the DLL has been loaded into memory. Then it checks if it's in the list of known DLLs, which are like DLLs that have been previously loaded or are commonly used. Then it will check the directory from which it was loaded, and then it checks in System32. If we are building a desktop application with safe DLL search mode enabled, which that's a registry key that's set for like the whole machine. It searches from where the application was loaded. Then it looks in the system directory, like the System32 directory. Then it looks in the system directory, and then it will look in the Windows directory, and that looks in its current, and that looks in the current working directory. So like if you launched an application from like the desktop, like using a link from the desktop, or like you're on the command line and your shell was on the desktop, it'll look in that directory, and then it'll finally check the path environment variables. If you have safe search mode disabled, then it looks from where the application was loaded, then the current working directory, then it looks in the System32 directory, then system, and then Windows, and then the path variable. The big difference is, if you look at this, is that the current is where the current directory is searched in safe search mode enabled. The current directory is one of the last ones it checks. When it's not enabled, the current working directory is the second one it checks. So in order to successfully utilize a DLL hijack, though, we have to have access to a folder that will be searched prior to the legitimate DLL being loaded. A process that, or if we want to use it for privilege escalation, we need a process that runs in an elevated permission context. We need the ability to start or restart that service that runs in the elevated context. And we have to export the proper calls for the service calling it. Because if we just rename a random DLL to the name that we're trying to hijack and drop it in there, it's likely that the process will pick it up and it won't execute the proper function calls, and will either just the DLL won't work, or it could cause the application to crash depending on how critical those DLL calls are. So now we're going to get into kind of the more hands-on part. That was just the background. We're going to use Process Monitor, which is a really useful tool for finding this kind of stuff. It's part of the sysinternals package. It shows a whole lot of information. We'll get to that in a second. So we're going to go over how you can use filters depending on what your goal is to find. Like, are we researching like an individual process? We want to see, like when Windows Defender starts up, is there something we can hijack there? We can also set our filters to look for when system is being when everything's being loaded as the system user, and then we can also just look for any hijackable DLL, depending on what we want to do. So just to show you guys, we're gonna do a quick demo of this using a DLL to hijack Discord. Actually, is what we're gonna show. So if we just turn on Process Monitor with no filters, you'll see it just starts. Actually, my filters are still in place. So reset filter. Yeah, there we go. So you'll see it's just thousands of entries instantly, which is really difficult for us to find anything useful in here. So what we'll do instead is, so we're going to target Discord. We'll stop capturing and go ahead and clear the display. So we can put in a filter that goes, it has a whole bunch of ways of searching for it. We're going to search by the process name. It says contains Discord. Then we will include it. And so I'm going to go ahead and kill my Discord process so that we can see what this looks like when I start up Discord. So we're going to start capturing and go into Discord. So Discord is going to start up, and we're going to apply our filter. And as we can see here, like there's still a whole bunch of stuff going on, like when we're just looking at Discord. So there's this column over here that's called result, and you'll see success and then things called name not found. What we're really looking for is that name not found. That means it attempted to access a file at that path location and there wasn't a file there. So we're going to go ahead and add in another filter where we're going to say that our path, or our result for this one, contains name not found. We're going to add it. We're going to click apply. And now we've further reduced what we're looking for. What is nice about Process Monitor is when you apply filters, it applies the filter to everything that has been captured since you started capturing, so you don't have to recapture the process every time. So this has gotten us a lot closer, but there's still a whole bunch of these things that are registry values that are being looked at and not found. These can be used for like COM object hijacking, depending on what is actually contained in those registry keys, but we're not going to go over that today. That's a whole different thing. So now we want to exclude the operations that involve the registry path. We're going to tell reg, then we're going to tell it to exclude, and we're going to add that, and then we're going to click apply. And so now we've got all of these DLLs going on here. And what's really kind of interesting about Discord and why we're using it as our example is, as you can see at this startup, it looks like it loads a large number of its DLLs out of, or attempts to load them out of this app folder, app data folder, which is, first, it's completely unprivileged, like anyone, or we can access that since it's in our user folder. And then it just gives us a whole bunch of different options.
Real quick, can you just go to one side real quick, just so people can see? I guess some people are having some issues seeing everything properly since it's so small. So just go to one monitor.
Oh, one monitor. Okay.
Still getting used to the new software, so sorry for some of those issues, guys.
Yeah. Is that better? Let's see.
I know somebody mentioned that they're having some static. I'm not getting any static from my end. If anybody else is getting static, just let us know. We might have to like reboot his like headphones or something.
Oops, that's the wrong one. Is where are we seeing the? Is that just questions from internal, or is it their Discord discussion going on?
They're just internal ones, so.
Okay.
It looks like only one person had the static issue, but at least the screen looks good now. So.
Okay.
All right.
Yeah,
sorry for interrupting.
Yeah, sorry about that, guys. Yeah, so now we have a whole bunch of these DLLs that we can potentially hijack. There's a few, drivers in here that we could further reduce if we want, using the filter. Back here, we could, go down and do a path contains and just add DLL. And we click apply. So now we just have to pick one. Honestly, you just have to either know DLLs that are useful for hijacking, or just kind of troubleshoot it. The one I ended up exporting was dxgi.dll. So as I said, we have to export all the proper functions for this to work. So I have this DLL export viewer that I got recommended to me when I was learning how to do this, by some people over at TryHackMe when I was playing with this. So if we use this to load up the DLL from where it actually exists, which is in the syswow64 folder, we'll see that we've got a whole bunch of functions that have to be exported. It's a little time consuming, but it's not that difficult to do. Using Visual Studio, we can just build a new DLL, and we use this pragma thing, pragma once, and then pragma comment, which tells the linker where we're exporting to. To make it a little easier, you should be able to export using the full file path. I just dropped the DLL into the Discord, the app data folder, and just renamed it to PWN, just to make my life easier, to make sure that the tech demo actually works and we didn't run into any technical issues. But you should be able to just tell this the full path to the DLL and then export it that way without having to drop the DLL co-located. So now that we've demonstrated, or I've showed you guys that, we would compile it, and I already have it in here in my app data folder. So we just have to go. I just have to rename it to do DXGI. And then, so Discord actually like constantly loads its DLLs. So you get a lot of weird stuff going on sometimes. So we might have to restart it, but we can see if it, yeah, we're gonna have to restart it. So I'm gonna go ahead and kill off Discord again. And then when we reload it, we will pray to the demo gods, or well, I'll show you what it does. Right now, all it does is just kick off a PowerShell process underneath Discord. So when we load up Discord again, if the demo gods are with us, I tested this last night, it'll kick off. And when we go to Task Manager, well, looks like the demo gods don't like me. Yeah, the DLL's there. It's always risky to demo live. Let me. Let's do a queer display and recapture. Actually, we need to change our filters because we don't want name not. We actually want it to be a success, but we want the file path name to contain that DXGI. Okay, so we'll apply. Yeah, we'll try restarting Discord one more time just to see what happens when we load it up. So we'll launch Discord. And yeah, it looks like if it doesn't work this time, it looks like the demo gods are just not with us. Because as we can see, instead of saying name not found, like it was before, we see this success result. So it is loading the DLL we dropped in there. But for some reason, my PowerShell process is not kicking off. Do I have PowerShell running somewhere else? No. Okay, well, the demo gods aren't with us. We'll move we will move on to showing you with Invoke PrintDemon because we checked that this morning. We know that one is working for sure. So going back to our slides. Sorry for the demo fail, guys. FaxHell and PrintDemon are two different security vulnerabilities that were released by IanoSecu 007. His website's called Windows Internals, and FaxHell is a DLL hijacking vulnerability against the fax service because it runs as a privileged service, and we can restart it or start it whenever we want. We have access to it, and it runs in an elevated context. It runs as system. So the DLL if you go download the FaxHell DLL, it creates a bind shell that you can access through port 9299. We modified it a little bit for Invoke PrintDemon to kick off a PowerShell process instead of just a standard CMD bind shell like they did. And then PrintDemon is a CVE that provides persistent arbitrary write access to anywhere on disk. It turned out that when you ran, let me pull up a machine and I will illustrate it. But it turns out that when you added a printer port, because Microsoft supports things like print to PDF and that kind of stuff, you could set a printer port to a file instead of a port to, like I said, to support like print to PDF and that kind of stuff. But there was no permissions check on where that file was being written to or the port that was being added. So anyone could add a port that prints to a privileged location on disk, which makes it very easy to take advantage of that system32 file loading path issue that we were talking about. So I'll just show you real quick what it looks like. So I'm running as just a standard user right now. And we could add a printer port and we could add it to wherever we want. So we can add it to C, Windows. Let me just double check so I don't miswrite it. Local disk, Windows, System 32. Yep, there we go. C, Windows, System 32 / test.dll, and it just is perfectly happy to. Oh, access was. Oh, did this machine get? Oh, whoops. That machine got connected to the internet and patched. That's less than ideal. Man, demo gods are not with me this morning. So we'll log in. Windows. Oh no, don't tell me this one's broken too. Okay, I'm gonna pass this over to Coin because he's got the demo that we're gonna do with this anyway. So I will talk through it. So Coin, I'm going to make you the presenter.
All right.
Yeah. There we go.
All right. Hopefully that's clear and everybody can see. I'm going to walk through the demo here, and then Hubble's actually going to talk through the whole thing. So I want to mute myself.
So I just need to be able to see your screen. Hold on one second, Coin. There we go. Okay. Coin, can you go to the test box first and just show the add printer thing?
And what was the command again?
So it's add tac printer. And then just the name of the printer port. So C : /Windows system 32, and then just some random file name. Oh, I'm sorry. I'm an idiot. It's add printer port, not add printer. That's why it keeps failing. I'm an idiot. I'm sorry, guys.
And now I'm stuck in an endless loop.
Yeah.
Just like this.
Yeah, and then the printer name, report name. Your VM is not happy.
Yeah, demos aren't going great today, guys.
It's because everything worked during George's red team demo for Mayhem. Oh, so it successfully worked that time. There you go. It was just freezing. So now if you do like get printer port, it should be in there. Yep, there you go. See how it says the C Windows system? That's your printer port that was added. So there we go. Successful test that time. Okay, so now we can walk through the Invoke PrintDemon stuff.
Some people are saying it's really small again.
Yeah,
Unfortunately, I have a ultra wide monitor, so I think that's not helping the problem. Because I only have one screen shared at the moment. Let's see if there's any way I can modify that to make it a little easier for some people to see.
you can you zoom?
It's not letting me do any of that stuff.
Can you just make the Windows VM take up more of your screen because it's only taking up like a fifth of the screen on the left?
Oh, yep, I could do that. Well, actually, no, because VirtualBox hates me, so it doesn't actually make the screen any bigger. We won't be doing anything else in the Windows box anyway from this point on, so everything's going to be in the Kali machine. I'll just zoom in to make the Kali one a little bit easier to read, so that way we don't run into issues over here. If I remember what the hotkey is.
You just hold Control and scroll.
Nope, doesn't like that either. Well, we'll just have to go from here.
Just maximize your VM screen. Like don't show the Windows screen. There we go. That should be better. Okay, so getting into it, this is the Try Hack Me box that we have. Just fair warning, Try Hack Me is a new platform, and it's promising, but they are running the machines as nano machines in the Amazon cloud, and so they are very slow and sluggish, and sometimes we've been having issues getting the Invoke PrintDemon chain to work fully when it is uploaded into the Try Hack Me. It'll work locally with the machine configured properly, and as soon as we upload it there, because of the resource constraints, there's something going on that's preventing it from working properly. So Coin, are you doing anything yet or no?
Not yet, so I can start now. I'll start the Empire stuff going and the WinRM. So if you want to walk through
that. Sounds good. Yeah, so the Try Hack Me box is set up so that you can log in through WinRM initially, because it allows you to just get an initial beacon going on the machine as a user. And so we will so he's going to set up a port if he hasn't used all of his ports for other things. Yeah, so he's gonna set up. You already have a listener set up, Coin.
I was just going through to show how to do it.
Oh, okay. Yeah, so Invoke PrintDemon uses that add printer port vulnerability to write a DLL called ualapi.dll that's loaded by the fax service to hijack. And what it does is it'll start part of all of the other part of the chain is it turns out that when you have printer jobs that are not completed and spooler is restarted, they lose all association to the user privileges that they were started with and have the privileges at system. So we can add a printer port to write wherever we want, but it won't actually let us write there while the print job has the user association because we don't have the authority to write there. But if we restart the spooler service, which the easiest way to do that is to just restart the box. And we get some people that say like restarting the box isn't realistic or whatever, or like OPSEC safe. But if you add a pop-up to the restart command that says your organization has pushed updates to your machine that requires a restart, and just do a forced restart and do like a 15 or 30-second countdown or whatever, no one's going to question that's what's happening. I would assume that everyone in here has had that happen to them at some point at their job, where it's the policies they have in place just force reboot your computer in the middle of work. So we don't really see it as that much of a limitation. The bigger limitation would just be since we're not trying to do anything malicious, if we're rebooting people's boxes, we want to make sure that you set like a restart time, like I said, 15 or 30 seconds as an example, because that's kind of what happens sometimes in a corporate environment. But if we use it on an operation, we typically give them a couple of minutes to make sure that a user has the chance to restart or save anything that's going on and all that kind of stuff, because we don't want to kill someone's work by accident or anything. Or we might just have the organization give us a box that we know is okay to restart, just for the proof of concept for them. So when it restarts, because print jobs are persistent through reboots, you've restarted the spooler service, and now your print job has system level permissions, and it writes into that privileged location. So Coin is now kicking off his beacon in using WinRM for the initial foothold that you'll use in Try Hack Me. And then are you gonna go back to Empire now, or?
Yep, so I launched this one off. That's gonna bring back our agent here, and then you can walk through some of the limitations with WinRM.
Yeah, so it turns out that WinRM has some really weird limitations. If you hold on for a second, Coin, before you go, I'm gonna draw on your screen real quick. If you look over here at the, I need to use a color that is not black on a black screen. We will use green. If you look over here under look at his agents where it has the IP addresses, when you're in WinRM, you don't get an IP address back. WinRM has some limitations because of the stuff built into PS remoting to limit its capabilities, that breaks a lot of functionality for what we do in typical like Empire usage and PowerShell beacons. So you have to inject into another process, which is good practice anyway, like OPSEC practice anyway. You don't really want to just kick off like a random PowerShell process and not and just leave it there. We want to migrate into a process that's less suspicious. So we use Explorer just for the proof of concept stuff, just because it almost always works. And that gets us, because when we inject, it's a PowerShell session reaching back to us instead of us enabling a remote PowerShell session, which is what WinRM does. It's not an actual remote session. It's a local session, so we have all of the rights and capabilities of normal PowerShell. CTF cracker, it's the CVE that allowed that was patched in the May patch Tuesday release of Microsoft. So any machine prior to the 2004 build of Windows that hasn't been patched is vulnerable to this attack path.
And to circle back, one of the things that Hubble brought up, the remote session has a lot of issues. So if you try to run Invoke PrintDemon directly from your WinRM session, you're going to get a bunch of errors, and it's not going to be able to be successful. So what you're going to have to do is migrate to another process before you actually execute this attack chain, if you're using that as your initial foothold.
Yeah. But if you use something like a malicious Word document or something like a malicious macro or something, you don't have that issue. It's just if you kick off your initial foothold with a remote session. So yeah, we'll do a PS inject and then the job started, and we'll wait for it to call back. Does anyone have any other questions? I'm sorry that our demos kind of have been a little bit skewed today. We tested them last night and everything was working, and then demo gods weren't with us today. The hazards of doing live demos. Let's see, we got a couple of questions. Yeah, so Tobias, there is a Try Hack Me room that we've built. The link's in our Discord. And then, yep, doesn't look like we have any other questions in here except for the screen being small. And yes, Tobias, the slides and code are available after this. The code's already in our GitHub under Invoke PrintDemon. And under Invoke PrintDemon is also preloaded into Empire under our Git repository. So now Coin's gonna be kicking off the PrintDemon module in Empire. So all you have to do here is set your launcher code. It says set launcher code because in Empire, that's what you're almost always going to be using it for. But this can actually execute any arbitrary PowerShell code as long as you provide it as base64 encoded.
I'm not sure if you answered this question from Marshall. He's having some issues with Try Hack Me. Just to circle back to that, yeah, their machines have limited resources, so sometimes those things are going to time out and have some issues. So just keep that in mind when running the Try Hack Me, that sometimes you just have a really slow machine and it might take a while.
Yeah. Yeah, they're a new platform. They're pretty cool because it's it allows us to upload machines for people to use that without costing a whole lot of money and give access to you guys, and then we don't have to worry about maintaining the infrastructure or running it all the time. So we're hoping, and they're, like I said, they're fairly new, so we're hoping that and they're planning lots of upgrades. So we're hoping that it'll become more usable as it goes along, because the machines can sometimes be super slow and crap out on you.
Now I know this is a little slow, but what you can see here is that Invoke PrintDemon was successful. It popped up that error message, and it has the document already queued up with the printer called PrintDemon.
Yeah. Oh, if you could scroll over, or no, it's right there. So I know it's small, guys, but if you look, it says that that the print job's in an error status, and that's because, as I mentioned, when you kick off the print job initially, it still has your your user permissions so that it can't write there. But we're leveraging the fact that because it's an error state, it'll stay persistent through the reboot, where it'll lose the user association and be able to print there on reboot. So if you want to go ahead and reboot the computer. So, and what Invoke PrintDemon does for this part is it just uses userland registry persistence currently, and when the FaxHell DLL is loaded, it then executes the registry key and connects to the process that is kicked off. Actually uses a loopback address to connect to that port 9299 to execute the code. And I built it that way just because it makes it much easier for us to implement it so that you can execute any arbitrary code without any like significant length of command or anything like that, so that you can use all of the obfuscation and stuff you want, because it's just passing it over a loopback TCP connection. Yep, and then as you can see, I'll go ahead and draw on his screen. He got a callback from the machine, and it's in the system level now instead of just a standard user. From here, like something you'd use this for would be to then inject to like a admin on the box, so that you could then elevate your permissions to local administrator that would allow you to pivot, because you actually can't pivot lateral across the network from a local system context. It doesn't have the rights to move to laterals across the network. So when you go through a full kill chain on a like initial foothold, you typically go from standard user to system to your local admin user, and then elevate your permissions to bypass UAC, typically from a medium integrity process to a high integrity process. So cool. Now that was kind of all we had for you guys. If you have any questions or anything you'd like to see have me re-show you guys, whether it's the process monitor stuff or anything like that, let me know. Yes, we will put this up on YouTube. Yeah, and then just to reiterate, we have a training course going on at the end of June. It's across 2 Saturdays, June 20th and June 27th, where we'll be going over the threat emulation for red teams. We'll go through the entire kill chain from initial recon to information exfiltration, effects employment, specifically focusing on how you build emulation plans to like go at like after a specific threat actor or something like that, because that to us the big difference for red teams and pen testers is that we're emulating real world threats. And so when we do an assessment as a red team for companies, we actually tailor the threat that we are emulating to the customer that we're using. So like if it's a financial company, we emulate a different APT than if it's someone that's just, like a small business that's got like, that does like Bluetooth locks or something like that. We emulate different levels of PTTs and that kind of stuff. It's 2 days CTF Cracker. And so, yeah, and we also go through like, someone like a Fortune 50 company has different concerns than, someone that's got 10 employees and just wants to make sure that someone that's just throwing random code to every box on the internet isn't gonna break their stuff. So like we talk about all those kinds of considerations for tailoring and how you emulate your threat and that kind of stuff, as well as teach like a lot of these techniques and types of stuff about how you can implement them as well. Oh, sure, be it. I can bring that back up. Coin, can you pass me back the presenter, please? Oh, well, that's a new one. Hold on. So this software has this thing that allows us to hide all of my desktop icons to make it look cleaner, but it also hides it from me, so I can't open the things that I need. Okay, so now we'll go back to. Okay. So let's see. I'll walk through just start to beginning since that's what was asked. So we'll stop capturing and we'll reset our filter. So typically, like I said, what we're really looking for is we either want to look for any like hijackable DLL or look at a specific process that we think might be hijackable. So if we want to look for just any hijackable DLL potentially, we would go over to our path, which is this section here, and we want it to only show us files that contain .dll, and we want to include that, so we'd add it. Then we would also add an exclusion for our operation for registries. So we'd go to operation. I always have a hard time reading this. Contains reg, and we would add an exclusion for that. And then the final filter, so if we apply that, we now are only showing DLLs. And then the final thing that we'd want is to restrict our result to the name not found. Because if we have a success or any of these other things, that means the file was loaded and used properly. And we want to include that. So we're going to add it, and then we're going to apply. And so as you see now, we just have this DLL from Discord that's just constantly being said it can't be found. Most of your DLLs are going to be found, or that you're going to see these kinds of issues with, are going to be on startup of the app, not while the app is running. Because while some like the apps do reload DLLs and stuff, sometimes most of them don't. They just load what they need at startup. So if we kill Discord again, and we go ahead and kick it off, we should, oh, that's why I have my capture turned off. That's not helpful. So yeah, so there we go. We will kick off Discord again. So now we have all of these DLLs that were not found. How you pick one is just kind of, like I said, either experience, like version DLL is used a lot because it has it's relatively easy to export the functions from it and that kind of stuff. If I bring up my Visual Studio Code, that's where we do all these exports here. I can try rebuilding the DLL one more time, and we can just kind of start from scratch and see if this hijack works for me. So what we want to do is we're gonna go delete this PWN DLL that I was using to try and make sure it worked. Yeah, so it's loaded by Discord, so I'm not sure why our PowerShell process didn't kick off. But we'll have to end Discord so that I can set this up all the way again. We'll end task there. So we will, so we know that's the right DLL now. So I rebuilt the other DLL. And I called my solution calc because I was initially trying to have it pop the calculator, but then I decided to go ahead and make it launch PowerShell. Go here, grab this and go back. We want to say, okay, I already removed the DXGI. I'm gonna rename this to dxgi.dll. Now it's in there, and then we will kick off Discord one more time to see if the demo gods smile on us. Oh, hey. Oh, it was open for a second, it looked like. But nope, demo gods are not smiling on me. It worked last night. Coin can attest to it, but oh well. So.
And once you're done with this one, somebody wants to go over some of the Invoke PrintDemon stuff again. How to use the specifics inside of it in Empire.
Oh, in Empire? Okay, you wanna do that, Coin?
I'm booting it up now if you want to start talking through it after you're done with the Procmon stuff.
Okay. So one thing we can try that might break my Discord if we do it. We're gonna try one thing real quick to see if this works. Is I had a limitation in here to make sure it only launched once, and maybe that is tripping it up. So we will try one more time just to, well, Coin is booting up his stuff. To Control C it. Back. Yeah. Yeah, see, it says that it was loaded into Discord. So our DLL is working. I just don't know why the PowerShell process is not launching. We will rename this DXGI. So last time I tried this, it actually crashed Discord because it launched like 100 PowerShell windows. Oh, yep. So as you can see, the DLL is launching a whole bunch of stuff and it's kicking off. So I don't know why it wasn't kicking off one process like it was supposed to, but we now have hundreds of PowerShell processes being spawned underneath here. So we at least got this to semi-work. Yeah, so it crashed Discord because of all the very large number of PowerShell windows that we had running. Okay.
So once you're done killing that,
Yep.
I have a Explorer agent running right now, so you can walk through the Invoke PrintDemon stuff maybe in a little bit more detail on how to use it for the specifics.
Yeah, okay. So if you wanna, I will pass you back the presenter thing. And while you're doing that, I'm gonna kill off my my DLL so that I can watch Discord and be in the chat again. Oh, stop it. There we go. Okay, so yeah, if, Coin, if you go ahead and do use module prevesc PrintDemon, go ahead and just enter into the module. And then type info. Yeah, thanks. So what this does is it has an agent, the launcher code, and printer name. It actually might be easier if I, you want to pass it back to me, Coin, and we will, I will actually just bring up the code in PyCharm, and we can walk through the code real quick to make it, just so people can get a better idea of what the code actually looks like.
Okay, it should be back to you now.
Yeah, it is. And while we're waiting for PyCharm to load, has people's questions been answered?
Looks like it. And it
Okay.
looks like Marshall was able to get try hacking to work, so that's good news.
Oh, okay. So this is is this too small for people? Let me see if I can make this any bigger.
Looks good from my point of view.
Okay.
How about anybody else? CTF Cracker says it's good.
Okay.
And Kim. Okay, so it looks like we're good.
Okay, so this is the actual PowerShell module. It only has a couple of options right now, which are the printer name and the launcher code. I'll probably update it at some point so you can set the file name as well. So when you patch in your launcher code or whatever, really, like I said, whatever arbitrary PowerShell you want to execute, it comes down here and it adds on this set of commands, which are actually for cleanup. Because when we do this DLL hijack, if we leave it in place, that UA, LA, PI, DLL in place, PrintSpooler also uses it. We get away with it on the first restart because the file isn't in place when PrintSpooler spins up, since PrintSpooler is what puts it to the location. But on subsequent restarts, you'll break PrintSpooler and break the printer jobs like permanently. It also can hinder the fax service from starting as well when PrintSpooler is not working. So this just kills the fax service process because FaxHell kicks off the PowerShell process under a different service, so the fax service doesn't need to continue to run. So we kill off the fax service and then remove the DLL just so we don't break the machine for subsequent restarts. It just makes it a little more OPSEC safe for using in a production environment. So then what you're doing as you walk through is you're adding the print driver to the that is a generic text only. There's some other ones that you could theoretically use. This is just the easiest one because it doesn't mess with that much, mess with your stuff that much when it's going through. Then we add our printer port to the location that we want to print to, which is at system 32 UA LAPI DLL. Actually, if you guys, so like you use process monitor to see that when you kick off fax service that doesn't work. Then we're adding a printer name in because you have to attach your driver and your port to a printer to be able to reference it. Then we use some C# code to export some calls from DLLs, because if you just send the code or your code directly to the DLL directly to the printer, just using like print and then the job, it formats the file into like a normal printer job. So like it adds like margins and all that kind of stuff, and it totally breaks the DLL. So using the C# allows us to bypass the spooler that does all of that formatting to ensure that our job gets written properly and we have an intact DLL in place. Then this is where we have this PE is we have compiled the DLL and converted it to a base 64 string, so that it is actually held into in the script, so that the DLL doesn't have to be dropped to memory and then printed to the location. It just reduces the amount of times we were hitting disk. So theoretically, you could also, if you had a different DLL that you wanted to use other than the FaxHell DLL, you could base 64 encode it using PowerShell, or Python is what we typically use for doing like the files because it's a little easier. And then drop it in here to use whatever arbitrary DLL that you want. Then this just exports or loads the C# exports that we did into our PowerShell process, and prints and does that where I said that it bypasses the spooler to print directly to the printer, is what's being executed here. Then this final section is where we use the registry persistence, which this is basically just the userland registry persistence code that's already in Empire, just modified slightly, where we say that we are starting the fax server, and then adding the FTP server and all that stuff to connect back to our launcher code. This is I'm sorry guys, I'm not speaking well right now. This is what I said. We use that loopback connection to talk to the FaxHell DLL so that we can send that we can execute arbitrary code. So theoretically, you could also modify this so that the agent that is kicked off and talking to isn't kicked off in the FaxHell process like it is currently, but that you have an agent that just has a persistent connection to the FaxHell, which would be, again, some of this we purposely don't weaponize fully just to send out, because in a production environment, it would be really, really suspicious to have a system level process calling out of the network back to a beacon. So the more operationally proper way to do this would be to set it up so that the beacon that calls back to you just has a persistent connection to the FaxHell process that was kicked off, and just passes your code, and is just a pass-through that passes your code up to the system level for execution, while maintaining its medium integrity standard users processes so that it would look like standard web traffic going out. But that's part of the reason why it's built this way, so that can be done in the future if someone chooses to operationalize it that way. So that's just what's kicking off. And then down here, the next sections, the last 3 lines, are just adding it to the registry so that it is kicked off when the user logs back in. I guess one other limitation that we haven't really talked about is because you're in a standard user, when you're doing this, you are limited to only putting your registry persistence for that user. So if like you restarted the machine and that user left and went somewhere else and someone else logged in, you wouldn't get your callback. You're relying on the same user to log back in, which is typically a good assumption, you know, since everyone has their own computers nowadays, and in most operational environments, when you're testing like a big company or something like that, they're typically not using shared computers. But that is a limitation that you have, since you can only do user LAN persistence until you gain higher privilege access. So then, did that answer people's questions, or did people want us to walk back through what Coin did all the way through the Empire?
I think that was really good in my opinion.
Okay.
One person, looks like we have another question from CTF Cracker. Will it still work if we're in a restricted domain environment?
What do you mean by restricted domain environment, CTF Cracker? Do you mean like domains that you're allowed to talk to, or like, can you expand a little bit on that? I'm not sure what you mean there. They don't have access to C. Yes, as long as this vulnerability is in place, it'll work. Is like, so if you were like in a constrained language mode for PowerShell, then obviously, since this is all running through PowerShell, you'd have to escape the constrained language mode first, which can be difficult. But as long as you have PowerShell and the access and the PrintDemon vulnerability hasn't been, or sorry, yeah, the PrintDemon vulnerability hasn't been patched, then you could do this even without access to C. That's why the CVE is kind of a significant one, even though Microsoft actually rated it kind of low. Is this gives you arbitrary write access to anywhere on disk. Yeah, so the major restriction is you have to restart the Spooler service, because that's what strips off the user permissions from the print job, is Spooler restarting. So if you have a way of crashing Spooler without crashing or without rebooting the box, you could do it that way, but that's not a since it is a protected process, it's easier said than done. Now, sometimes printers are famous for crashing their stuff themselves. So, if you're in an environment and they have a printer driver installed that is known to be an issue for print spooler, you might be able to crash the spooler process that way. But more than likely, you're gonna have to restart the PC. So cool. Any other questions?
I don't see any other questions at the moment. We'll hang out for another minute, and then we'll turn off the video, and then we'll be in the Discord channel if anybody has any other questions or is running through the tutorial and the walkthrough on Try Hack Me and have questions. We'll be happy to answer those as well. We also posted a link to our 2-day course. I know we already told you guys this before, but in case anybody else jumped in, if you're interested, the link's in here to sign up. We're offering 50% off right now if you're on our Twitter. We have a discount code on there, freelancer. We're really targeting trying to get it out to the public right now. I know normally a lot of these trainings are really targeted for corporate people, so doing it on Saturdays at a much discounted price to really help people out.
Cool. Well, I'm gonna go ahead and close down the stream, and then we'll talk to you guys later. So have a good one.